Today I want to show how to implement offset QPSK modulator, and you can expand it to other modulation type if you like. Before of anything, you need an input source, so you can use a random source or source file. I use a random source, but you can also use file source and read bit stream from file. After that, you need a constellation modulator for generate your desired modulation constellation. Also, you need to define a constellation object to specify symbol mapping and constellation points. Here, I defined a gray-coded QPSK constellation object. This block also need to specify SPS, that means number of sample per symbol. This block apply also pulse shaping based on SPS. I should say, as you know, sample rate here is the working rate of the first block, and because in modulator working rate is in fact the symbol rate, so here sample rate is equal to symbol rate. So after the constellation modulator, the sampling frequency rate increases by the SPS multiplied by sample rate. After this, we separate real and imaginary part of samples, because for offset QPSK we need a half symbol delay in a Q channel, that means in an imaginary part. We put SPS divide by 2 delay in a Q channel, and after that you need rational resampler to adjust the final signal sample rate to FS output variable, which is the sampling frequency you want to be the sampling frequency of your output signal. FS output variable in fact is the final sampling frequency of the output signal. After that, we use an up converter to transfer the signal to IF. So here the FFC is the signal carrier frequency. After up converter, in the end I use this generated signal as the input for offset QPSK demodulator. And after the up converter, I write the signal in a file and use this generated signal as an input for offset QPSK demodulator, which I introduced it in my previous video. After run it, you can see the output constellation of the modulator. I should say here, as you can see, I set the FFC and symbol rate a bit different with the exact value of these parameters, so I adjust the cascade loop and symbol sync block parameters based on new condition, and change the loop bandwidth somehow to lock fast and accurately. You can check the output bit stream in a MATLAB using input function and see the output bit stream, and you can see the output bit stream is exactly like the input bit stream.